I think we can dive into writing a counter contract. Okay. So once you create for the first time your counter.clar file, you will see a bunch of statements already written out. And if you remember, recapping this again, that semicolon, two semicolons are the ones representing comments in Clarity code, in Clarity language. So these are a bunch of comments written out here. Let's add a description of what we are building. So we are building a simple counter contract, and what we are going to do is write a read-only function to be able to read the count value in our contract, so anyone can read the counter value. And then we are going to write another function, which would be, let's call it count up. And only the contract owner, the one who deployed it, deployer, should be able to call this contract. Actually call this particular contract function. All right. Now, before diving into writing those functions, if we will, whatever concepts that I discuss right now will be discussed in detail. So if you do not catch on what everything, if you don't make sense of what everything is doing, that should be fine. We will be covering all those topics in detail in our future session in the course. So first is that I said that we need to be able to fetch the count for a count value. This is a disclaimer. So the VS Code Clarinet Clarity extension does not work on my system, and I don't know why that happens for me. It works sometimes, it doesn't, so it's an intermittent issue for me. So whatever the way I'm writing in my VS Code today is going to be completely manual. But if you use the extension, we mentioned yesterday that using the extension, you will be getting auto completions for the functions and any keywords that you are writing. So that would be possibly a difference between the way you tend to write and the way I am writing. So sorry about that. So the first thing that I'm going to do is define a variable which I want to store on chain and which I'm going to update. So define data var is the function which takes in three values. First is the name of a variable. I'm going to call it count. You need to define what type of variable, what sort of data this variable is storing. It could be a number, it could be a string, it could be, a buffer value, a list, or tuples. These are all types in Clarity. So for now, I am going to say that it is storing a positive value, and a positive value is declared using uint, which is an unsigned integer. So I'm saying that this variable count is of the type unsigned integer, and its initial value is going to be u0. So you can consider this data variable you can compare this to let in JavaScript, where you are able to update the value of any let variable at a later point. So this is the first step. We have a count data variable. Now, hopefully, with practice, you will be able to get comfortable with all the parentheses I have. quite a bit now. And you will see how simple it becomes when you're writing. You know, there is some sort of simplicity and clarity in the Lisp language. So, okay, moving on to the first function. This is get count. If I want to read this count value from onchain and find out what the current value is, what I would do is write, I'm going to remove this. I'm going to write a read only function. Now, we discussed yesterday, day before yesterday, just a bit that how we have different sort of functions available in Clarity. And for reading purposes, we make use of defined read only functions. Then we give a function signature, and then we give this function body. The function signature includes the name of the function, and the function name here, I'm going to call it getCount. There are no arguments available. I don't want to send any sort of input argument parameter to fetch any sort of result. So this should be it. This is how my function signature would look like. If there were to be any sort of arguments, they would be included within another set of parentheses. So for now, it's just a function name. Now, to be able to read this count value, what we do is var get. This is the function, and we give the name of the on-chain data that we want to read. So var get and count should return you the initial value for the count. Okay. Now, without probably waiting further, what I'm going to do is, first of all, Clarinet check. It tells me that I have one contract and it is able to successfully check the syntax for this contract. That means whatever I've written works fine and we should be good to go. And when I say good to go, we can open the console. Now this outputs me the contracts that are available in my project and the public functions that are available to interact with. So this is the contract identifier, and this is the get count public function that we just wrote. So what is this contract identifier? Now there is something called principal, which represents the in very simple terms, the wallet address, the account address for you. So let's take a step back. Let's go to DevNet file and let's look at this address. You will see that this account is the deployer. It's ending with GZGM. And you see that the contract identifier contains this tax address ending with GZGM. So the contract identifier here is a combination of the stag's address, who is deploying the contract, along with the name of the contract. This all together tells you that this is the contract principal or the contract identifier. Now, how do we make a call to this get count function? I'm going to write a bunch of keywords here and try to make sure that you're able to understand how to make a contract call. So contract call is made with this function. This is a function contract call with a question mark. And then what we write is the contract identifier for this contract. Now I have this contract principal. So first of all, I give which contract I'm calling, and I am calling the counter contract, which was deployed by this principal. Now, the principal in Clarity is prepended with a single quote. This is how Clarity reads that this is a wallet address, a stacks address, or a principal in Clarity. So you have this, and then you have the counter, which is the contract name. Now, when we have the contract identifier, we need to also specify the function that we are calling. Let's go back to counter. The function that we are calling is getCount. So you give the function name. We don't have any input parameters, so we can just go ahead without entering any sort of parameters because it doesn't require any. And now when I enter, you should see that the initial value U0 has been printed. Now to give you a very much more realistic view of the count, let me update it to U400, let's say that. Now you see that I had to get out of console so that I can check the updated contract. So you will have to do that a little bit, that if you make any changes to your contract, you would have to get out and restart your console again. And if I try to make that contract call again to my counter contract to the getCount function, you will see that the initial count has been displayed as U400. So basically, the Clarinet console, what this does is kind of creates a simulated blockchain, and that is how it is. We are able to interact with the contract that we wrote. So that simulated chain, in the backgrounds, what's happening is there is a blockchain sort of running, and we are able to see that this is the contract that was deployed with these functions, and then we can make that interactive calls to the contract. All right, moving on. This was the first function that we wrote, how we can read a data from the chain. Now let's write a count up function. Now, read-only function is something that does not perform transactions. You will see that we are just reading something. We are not performing any transaction. But if we have to perform an action, actually perform a transaction, we need to be using another function, which would be the define public function. So we define a public function with the function name that is define public. We give a name to the function that would be count up in our case. And then we would do var set count, and we would set a new value to it. How do we set a new value? Let's say that we are incrementing the count value by 5. So we are adding unsigned integer 5 to the count value. Now, internally in internal functions, you still cannot read the count value directly. This is also basically fetching the count value from chain. And whenever you want to read a data variable, you have to use the function varget. So varget count fetches you the count information, the current count from chain, and then we are adding unsigned integer 5 to it, and then we are using var set to set a new updated value on count. And this is it. I'm going to exit the console and restart it. Okay, and it says that public functions must return an expression of type response, and it found Boolean. So I want to quickly mention this, that all the public functions, they need to be wrapped in a response. So we will talk about this in the future session. I've said that a lot now, but this example is to showcase how we can, interact with a contract and help you with understanding of how the interaction takes place. So for now, I'm going to let it be. This is a response type, and a public function always needs a response type as a return value. So you did see that Clarinet console does not allow you to open a console if there is any sort of error. So Clarinet check is not the only, so Clarinet check is not the only command that you would need to check the contract. If you directly run Clarinet console, it would not open a new session if there is any sort of error in your contract. And now you will see that for your counter contract, we have a new function added, that is count up. Okay, so let's call this count up real quick. And how do we do that? We do contract call, we give the counter contract identifier, and then we are calling count up. It returns OK true, and I am assuming that this var set returning true will basically means that it was successful. And let me now call get count and see if it was actually updated on chain. So you will see from 400, it has incremented to 405. I can do this a bunch of times, count up, and you will see that my count on-chain data variable is updating every time. But I mentioned here that we want the count up to be only called by the contract owner. So definitely in your projects, when you work, you will have to validate certain things, and then you will have to provide certain trust to certain people, for example, to certain wallet addresses, for example. Only those should be able to call into the function. To be able to do that, what I'm going to do is quickly say, quickly first of all write define a constant. How do you do that? You have define constant as the keyword. Define constant takes a name of the constant. I'm going to call this contract owner, and I'm going to set this constant as tx sender. Now tx sender is a keyword, and this keyword is provided as a built-in keyword available in Clarity, which tells us who the contract caller is. So the transaction sender, the one who calls into the contract. So what we are saying is that we are defining a constant which is contract owner, and transaction sender is the contract owner. And once we have defined it, we cannot update this constant on chain. It gets written to the chain, and it cannot be updated. Now, what I said is that we should be allowing only the contract owner to be the deployer, to be the person who should be able to call in the count up function. So what I'm going to do is I'm going to showcase quickly that we have to write more than one statement within our function body. We mentioned that a function body contains only one statement at a time. To be able to write multiple, we have to wrap it in within the begin construct. So along with this, what I'm going to say is I want to assert that my transaction sender is equal to the contract owner. If it is true, well and good, it would increment this and update it on the count, else it would throw an error. And let's say that I want to throw error false for now. We will talk about this in detail later on, but for now, I just wanted to showcase a quick validation that we can add in our contract. And you will see a quick overview of why I talked about this assertion in this example. Now I am going to get out of the console, get into the console again. So transaction sender is a keyword available to us. You will see that the transaction sender by default is our deployer, the one ending with GZGM. So we get this transaction sender by default as the deployer for us at this point. And now I want to make a call to this count up function. Get counts, it's 400. I'm calling count up. It says, okay, true. And I get my count. It's 405. Well and good. Why? Because my transaction sender and the contract owner that I set before are same. Now, there is another command available to us that is set transaction sender. And within Clarinet, what we can do is, because this is a simulated blockchain, we can update the transaction sender according to us. And I can set it to a new principal. So what I'm going to do is, let me copy this. Okay. What I'm going to do is pick up a random wallet address other than this transaction sender. And let me pick up this and do this. So it will showcase that your transaction sender is now switched to a new principal that I set. And you can also confirm using transaction sender that it is not ending with GZGM anymore. That means it's a new user. It's a new principal that is going to call into the contract. And I mentioned here that only if you are the contract owner, you would be able to make an update. So I'm going to call get count. The value is 405 because I updated that a minute back. And now I'm going to call count up. Now you will see that it is returning error false. Why? Because when I made a contract call to the counter, to the count up function, it said that you are not the contract owner, and therefore you are basically unable to execute anything that is applicable to this function. And if I try to fetch the count again, you will see that it is still 405. There was no update made to count. This function returned me error false. So this is the way in this simulated blockchain you are able to update, simulate a different transaction sender, a different contract caller into your contract functions. And this is the way you manually test and interact using Clarinet. I think this was pretty much it with everything that I wanted to share about Clarinet, about what a project looks like, how we create contracts, what these Clarinet toml and devnet toml really mean, and the subcommands which you can use for Clarinet console and Clarinet itself. There are a bunch.
Hey, Akansha.
Yeah, hey.
Before we exit out of here, could you just real quick go over creating a Clarinet project, like from the start and getting into the directory, since we didn't record it initially?
Okay. Okay. All right. All right.
Yeah, thank you.
Okay. So how do I do that? Okay. I would probably get out of this. So how do you create a Clarinet project? This is the first thing that we need to do to start writing contracts. So I am in my current directory, which is work. And if I have to create a new project, the way I do it is using the command clarinet neo and the name for the project. So I'm going to call it maybe second contract. So once I do this, I'm going to agree to enable a hero to collect diagnostic and usage data. I say yes, and then we see a bunch of logs here on our terminal mentioning that it was able to create a new directory, second contract, and bunch of other files and directories. Now I am probably going to open a new window maybe. Okay, are you able to see my first screen or the second screen? Am I still on the logs?
Yes.
We see your
creating
first
a new
screen.
First screen, okay. I'm going to do a new share. Okay, I am opening a new terminal. I am going to open a new folder that I wanted to work with. I was under work and I created this second contract. And if I open this, it should open the second contract for me. And this is how you create your project using Clarinet New and the name of the project. And how you create your first contract would be Clarinet contract new and name of your contract. That would be, let's call it counter 2. So now contracts contains the counter2.clar, the clarity file. It contains the test directory, contains the TypeScript test file. And then in your clarinet.toml file, you will see that counter2.clar has been added as a configuration property, mentioning that these are the contracts that are available in your project. Now, I also want to mention that you can have multiple contracts within your same project. So if you go ahead and create counter 3, you will see that counter 3 gets added here. You have your counter 3 test available, and then Clarinet toml would also have a counter 3 configuration updated in this clarinet.toml file. Was this it? Or do we want to go in more detail?
that was it from my end, but
Okay.
the more detail, please, in the chat. I'm not sure regarding what though.
Okay, what we can do is we can take a look at all the chat questions. Do you think that all the questions have been answered, or do we still have a few left?
I think I got most of them. I was just responding to the questions about the contract owner. Maybe, do you want to show them the like testnet and mainnet toml files again, and just show them how, like when they go to deploy, um, they would enter their mnemonic into that file in order to set the contract owner?
Okay. So, okay, this one. So when we created our project, we have details. We have these files under settings that are devnet, mainnet, and testnet. And this is, let's consider this as a recap, real quick. Devnet would contain some test accounts for you. So those accounts are already hard coded for you, and you can directly dive into testing. So you have a deployer account, which is for me ending with GZGM. It might be different for you when you set up your project. It has the stacks address, you have the BTC address, you have the associated secret key, and you also have a default balance. This is the stacks token balance, and you have the mnemonics as well. Now, apart from the deployer, account deployer, there would also be other test account wallets created, wallet 1, wallet 2, and you can make use of these whenever, however you're working in your use case. The way I showed a use case was to update the transaction sender. That was one use case where I was making use of another stacks address. We have the mainnet file. Now, the name for the network is mainnet. You have some fee rate, you might update this, and the deployer is the one uh, who is deploying the contract. Let's say that I have control over the project and I am ready to deploy it. I will probably go to my Hero wallet. So Stacks wallet, the most popular, most used one is Hero. I would go to my Hero wallet, take a look at the mainnet config account details. I will probably find my mnemonic there. I will probably enter that here and then deploy it either on mainnet or testnet. Mainnet, for whenever you are deploying to mainnet, this is the file that you will work with. Whenever you are working with testnet, you will have to work with this testnet.toml file. So for this mnemonic, testnet mnemonic, you would have to go to your Hero wallet, find the mnemonic there for your testnet network, and add this here. And then there is a command. Okay, there is a command called integrate, which will, I think, sorry, not this. I think it is called deploy, maybe, not very sure. But you will be able to make a deployment directly to testnet and mainnet. And yeah, integrate is used for setting up your local DevNet network. That means you can, a Clarinet console, it creates a simulated blockchain, but integrate will create a dev environment blockchain. So it will actually spin up a Stacks node, it will spin up a Bitcoin node, and then it will run on a local host with some port, and then you will use this local DevNet setup to interact with your front end, probably, if that's the use case. So Clarinet help will give you commands that you can use, all the features that you can use with Clarinet. And I'm going to cd into first contract and say Clarinet console. This is basically spinning up a simulated blockchain. It is telling us what all contracts are deployed. So for now, in my contracts, I have counter. So it shows that this wallet address deployed this counter, and this is the deployer for your contract. And this is these are the public functions available for interaction. I think that was the starting portion that we discussed.